Hello and welcome to the SAC channel. This is Keith Willing, President and Founder of Southern Air Concepts. Today we're excited to talk about a new product that we think might work for you well. In the seminar today, we're talking about the new direction in HVAC. When I'm being joined today by Pat Downey with Nortech Global. Pat is our controls guru at Nortech Global. And we start talking about outside air, high outside air. It's important that we really look at the controls platform and understand the proper way to control and the implications involved with that. So Pat has joined us to talk on the controls side. But before we get started, I want to thank you for being with us today. We hope this presentation is meaningful to you. It's always a way to improve. So if you like, save some questions at the end. We'll jump in and try to answer those for you if we don't cover something. As we begin today, I'd like to talk about where we have been as an industry and where we are today, where we are going, and the possible solutions at the end. Years ago, back in the 60s, ARI came out with a standard that we pretty much live by. All the unitary manufacturers published their performance data based upon an 80-67 and a 95-degree outdoor temperature. That standard makes the assumption of 20% outside air. Well, back in the 60s, that was a pretty aggressive number. But today, things have changed. We've also, as an industry, evolved with this, different implications that have been benchmarks as we move forward. Certainly, we all remember the Legionnaire's disease and what that meant as far as, making sure that there's mold and no bacteria, the danger that could be caused by that type of bacteria growing in our systems. So that continued in the 80s when we talk about the sick building syndrome. So not only the bacteria that we talked about in the 70s, and we start to become concerned about VOCs. ASHRAE has always maintained their standard 62.1 as far as ventilation. And every year they make, reevaluate that and make minor adjustments. But there's a couple in 2004 and 2019 that were kind of considered major adjustments. And most of those had to do with the type of application and increasing amount of ventilation required by the number of participants in a given space. A challenge for us as an industry, especially when we're talking about a product for dealing with outside air, is the different climate zones. For example, are always pushing for more coil, where my counterparts in the north, especially in the upper Midwest, push for more heat exchanger. It's difficult to try to achieve all these criteria, especially when you talk about 100% outside air and the different variances that take place within those climate zones. It's not that constant 80-67 cooling design that we always look at. It becomes more of a challenge. Also today, we like to talk about the dehumidification standard. Certain national accounts, for example, the Hilton Group, has the dehumidification standard versus the outdoor dry bulb standard and wet bulb standard published. The reason of that is you can see the amount of grains involved. At the standard cooling standard, you can only have 97 grains in this Atlanta example. Whereas the dehumidification example for the Atlanta market has 131 grains. That's a significant increase in the amount of moisture, significant amount of latent capacity. So it's important that we look at dehumidification standard when we're talking about outside air. So pre-COVID, as an industry, we were feeling pretty confident about ourselves. We've had a good understanding of proper heat load calculations, had now amazing software to help us with those calculations. We've made progress as far as publishing ventilation standards on mechanical drawings. So when you go to the permit department, they can review that easily and verify that you're meeting the industry standards and the benchmarks set by organizations like ASHRAE. And we also knew it was important to have a healthy building, not only in terms of filtration, but also in terms of humidification, because a proper humidification between 40 to 60% slows the growth and transmission of viruses. What that means to us in the southern climates is dehumidification of the cooling side more so than on the winter type conditions. But my counterparts again in the upper Midwest, you know, humidification, especially winter humidification, is important. You don't want it too dry either. So between that 40 to 60% is our goal to try to maintain. So where we are today in a COVID world, we must look to mitigate our risk. As you can see by the quote in the Washington Post, that people aren't going to be inclined to go into buildings if they're concerned about how safe they are. And that works for not only the workers, but also the customers. Think about being able to publish on your door front that you have done things in a progressive manner to make that environment safe and making it more inviting for those people to come into your business. Those are the things that we need to start looking at evaluating on each application. So we're going to talk a little bit about that today too. To guide us, organizations like the CDC have put out a plethora of examples for different buildings of what they consider you should think about when you're designing your buildings, or you're modifying your buildings to today's standards and to make it so-called COVID safe. I've read most of these publications. Many of them may repeat a little bit stuff, but there's also some material in there that are unique to that type of business. And certainly, as you can tell, the ventilation standards are vastly different on each of those different instances. So take a look at those publications as it's pertinent to your project. Likewise, the OSHA has done the same thing in terms of safety considerations. They also have guidelines and recommendations that should be evaluated. And lastly, the guiding light of our industry, ASHRAE, has put out some publications too. They actually have a site devoted for COVID, and they actually have a task force too that is doing nothing but looking at recommendations that we should consider in designing buildings that are COVID safe. So all these also take a backseat to what local codes mandate. For example, ASHRAE may have a specific ventilation standard for some type of business, but local codes may override that in terms of a minimum standard. So in any instance, either a state or a local code will preside over what the CDC, OSHA, or ASHRAE may recommend to us. So what I feel is the direction that we're going is what I like to use in the acronym PDF. We all know that acronym from being involved in the business world, and we deal with PDF every day. So I've adopted this acronym to summarize what the direction we're going in the industry. P meaning purification. D meaning dilution. And F meaning filtration. So let's dive into these a little bit deeper. So on the purification side, there's two main types of technology that are being promoted, both the UVC and the bipolar ionization. Both have unique applications and considerations, and both are considered viable products for a safe building. As you can see, the UVC technology uses UVC spectrum to kill viruses and bacteria as it circulates through an HVAC system. Most of you are aware that oftentimes they recommend you put it over a coil surface too. So not only is it treating the airstream, but it's also treating bacteria and growth in the coils and or the drain pan as well. UV lamps do have a life, and you should be considered about replacing those and on a regular basis as recommended by the manufacturer, but they are also considered highly effective in destroying viruses like COVID-19. They do have some downsides to it too, and especially the direct contact with human eyes and skin can be harmful, so you should be trained in handling those things. You don't want to put yourself or your associates or your employees at risk. And as I mentioned earlier, they also have to be replaced on a periodic basis to remain effective. Bipolar ionization also accomplishes some great things in terms of air purification and creating a safe work environment. There's A lot can be said for this, and we can certainly go much deeper into the subject on a later webinar, and certainly reach out to us to talk more about this. But as you can see by the highlight in red, some technology that exists out there in bipolar ionization can reduce your risk by 99.9%. And we certainly feel that it's a very viable product, and there are certain products that we represent, like Atmos Air, that not only treats air in the airstream, but treats bacteria, UVC that is in the space. So it's a very active solution to your problems. Also, bipolar ionization be properly sized by somebody who knows what they're doing. And some bipolar ionization products give out ozone. So be careful when you evaluate those to look at products that do not emit too much ozone. And like UVC, you should consider what replacement and maintenance should be required in using UVC type product and also the bipolar ionization product. Dilution. This is where conversation is mostly directed today when we start talking about outside air. Dilution is the amount of outside air that you're going to put back in the building. And again, ASHRAE 62.1 gives us guidelines of what to do with dilution on the number of people, the type of application, how much outside air should be introduced into space. What ASHRAE and many of these organizations are saying right now is, at a minimum, a building should use the guidelines set forth by 62.1. But currently during the pandemic mode, they're saying the more outside air, the better, even of 100% outside air if it's possible. ASHRAE has made some recommendation of considering running the DOAS 24/7 and not using ERVs, to shut off your demand ventilation, to run your ventilation constantly, and consider a pre-purge and post-purge. For example, 2 hours prior to occupancy and then 2 hours after occupancy for purging. Filtration. ASHRAE is recommending the minimum of a MERV 13 or 14, where traditionally we've been using MERV 8 quite a bit. One thing I will say about the bipolar ionization, it can actually improve the effectiveness of filtration through a process called conglomeration. Bipolar ionization can make some of the small particulate larger particulate, which makes it easier for a MERV 13 filter to catch. So it can achieve both and improve the efficiency. So moving forward, you can see in a lot of applications that we're going to have a product that's versatile, that can handle more outside air to meet these standards. A lot of local codes require that ventilation standards be met when replacing existing rooftop equipment. So before, if you had that standard unitary product that had, up to 20% outside air per ARI guidelines, suppose a new tenant has come in and exhaust rates have increased, or it's a nail salon, you've got to have more outside air. Or again, you're just worried about mitigating risk in terms of COVID-19, so you want to increase your ventilation rates to make your customers feel good. So that dynamic often means a lot more outside air, which is what we have to offer you with the R7. So the R7 is designed for 100% outside air or high outside air applications. It is designed to fit many of the existing carrier models. As you can see by this chart, a lot of the typical carrier unitary product is going to be the same dimension as the R7, and we can fit existing curves, which helps a lot when you're trying to retrofit a unit and not have to worry about getting a curb adapter. Looking at the physical characteristics, you can see the dimensionally how close it is. And again, important to note is the MCA MOPs. As you can see by the notes there, We're very close in terms of MCA MOPs. What does that mean? Well, you don't have an expensive upgrade in your electrical. And most often the existing wire and existing breaker size can handle what you already have and also handle the new R7 unit. One last point, you can see the R7 is a little heavier. Well, the reason of that is the R7 unit is double wall construction. So it's more robust, higher quality. As you can see on the construction advantage, as I just mentioned, double wall, but we have a 1-inch foam injected panel. We have hinged access doors with locking rods, a direct drive ECM evaporator motor. I'm a big fan of these ZLA bag blowers. It's easier to go in and dial. Resner has 2 pressure ports, one on the inside and one on the throat of that blower, ZLA bag blower section. So we chart in our installation instructions what that pressure drop is. So a contractor with a manometer can use the 2 sampling tubes that we have at these 2 pressure taps and test the pressure drop, go to our book and increase the blower speed or decrease the blower speed accordingly to match what is shown in our literature. And test and balance is 90% done. Certainly I encourage you to use a test and balance agency, but you've come a long way to get the unit to perform where it needs to perform based upon the criteria that we have published in our literature. Our blowers have neoprene isolation. And of course, we have optional dampers for 100% outside air or outside air and return air. And it's important to note that our 4-inch filter rack can accommodate MERV 13 filters as they're recommending right now. The cooling options, as you'd expect, we deal with a lot of coastal areas. So we have electrofin coil coating, condensate float switch is an option. Our dehumidification circuit is a patented dehumidification circuit that can bypass 100% of the refrigerant if needed. It's a unique system that at part load can give you a very strong reheat performance. And as you would expect, we have a 5-year compressor warranty option. On the heating side, we have both gas and electric. Our gas modulation for natural gas is 6-to-1. For LP gas, it's 5-to-1. And of course, we have a stainless steel heat exchanger. Options for 10 or 5-year heat exchanger warranty, and our electric heat standard is SCR control. We are not involved in staging at all. We're coming out the door with SCR control as a standard platform on electric heat. At this point, I'd like to pass it over to Pat. Pat's going to talk to you about why it's so important for us to consider the controls options when you're talking about high outside air units. Go ahead, Pat.
Hello, everybody. Keith, thanks for inviting me to be part of the presentation today. My name's Pat Downey. I've joined the Resner team or Nortec team roughly 8 years ago, and have been putting the digital controls packages together for the high-end low fresh air option units since I've started with the Nortec. The distinction that we wanted to try to describe here today and how things need to be managed a bit differently on this equipment is really what it comes down to is the quantity of fresh air that you're attempting to admit through the unit. So you have a low fresh air category, which is essentially like a residential application. It's much simpler. Things like conventional thermostats can just simply request heating and cooling to operate until a desired space temperature set point is met. Where we and what Resner and what we specialize have specialized in now for many years, decades, have specialized in managing and delivering high fresh air quantities, and we consider that anything greater than 20% up to 100. The key reason managing high fresh air units differently than a direct space control, which is, again, simple, sensible temperature control off of a space sensor, is really to prevent air from feeling objectionable to the occupants. And it really needs to occur no matter where we are in the climate zone map that Keith showed earlier. There's always going to be a period of time in any of the climate zones where the outside air temperature and humidity are going to be either much higher or lower than we want to admit into a space. So that's the challenge. And what we do is we control the air temperature at the outlet of the unit. So with this discharge sensor that's shown on this slide, the high fresh air units are always attempting to achieve an outlet temperature. If we don't actually have a call to heat or cool a space, then we just manage the heating and cooling as required to maintain what we call a neutral value, right around 70 degrees. If we, in fact, have a unit that's equipped with a space temperature and humidity sensor, then what we do is we increase the outlet temperature on the unit for the duration of a heating call, and we decrease the outlet temperature on the unit for the duration of a cooling call. The idea that an occupant, if we're doing everything properly, really shouldn't necessarily even be aware that a unit's delivering up to 100% outside air. They should have the same comfort level as a low fresh air directly space controlled unit. Keith touched on the fan controls a few moments ago. We've got a couple of different options there, inverter driven or ECM, and we have various control options for supply fan control, anything from just an adjustable constant volume where you have a set quantity that's required and needed for the space at all times, to pressure controlled inputs, temperature controlled inputs that'll either increase or decrease your fan speed accordingly. We also have CFM measurement available on the R7 product as well for the supply blowers, where we can actually set a desired CFM, read that calculated value, and control to it, and monitor it and or control to it if desired. Damper control options, essentially we cover anything from a conventional temperature controlled economizer with a mixing box to an adjustable fresh air quantity from 0 up to 100%. Standard control control options. We've got the low fresh air options along with the high fresh air. So we have control sequences in place for either distinction that we're attempting to explain here today. Variable volume fan speed, direct space temperature and humidity control, along with space discharge air reset options for the high fresh air, BMS interface options for remote control and monitoring. As mentioned, supply fan CFM monitoring and control. We do have demand controlled ventilation and CO2 sensor options, though we saw the recommendations for some of this stuff was to just not depend on an IIQ sensor, at least during this COVID period, and to recommendations were pretty clear to run high fresh air and run it continuously. Standard duct smoke detectors, dirty filters, phase loss. We have a couple different unit display options, and convenience receptacles also. Keith, I guess we're getting into the portion now where we might want to talk about the Expedite options.
Yeah, I'll take it over. Thank you very much, Pat. That was very informative. A Resner exclusive is our R7 platform does have a 10-day Expedite option. Certainly, with the COVID world, components have been somewhat of a challenge, but we have still continued to offer that. But we're asking you to check with us on a pre-approved basis just to confirm what we've got. Like, we generally, our sub-suppliers are doing a good job keeping up with us, but we don't want to totally mislead you. So please check with us before you commit to your customer on that side. And as you already know, Resner has a plethora of options for outside air ventilation, heating, space. We have infrared. Our family offering is quite strong. So we've got many of the opportunities that are presented before you, and including VRF, we have a solution for you. I did get a few questions come in here. First question relates to our salt spray rating on our coils. The salt spray rating for coastal areas is rated at 6,032 hours of coil. The important to note, I didn't note this in the construction features, but I did mention the fact that our unit is double walled. What I did not mention is that the interior liner of the double wall is a Galvalume material, which has a 5,000 hour salt spray rating, which is very, very strong. So it's certainly going to have a long life and fight the corrosive environment very strongly. The next question is probably better directed to you, Pat. Can you join us back in?
Sure.
Okay. The next question, suppose a customer has a high outside air unit and the dynamics of the building or owner have changed to 100% outside air. Can our controls be modified or do we have to be replaced to be able to deal with that kind of scenario?
The controls, the way they're currently set up, they won't necessarily have to be replaced. We have these space control options and the high fresh air option control sequences are resident in the controllers, all of them, and they're simply enabled at the time of manufacturing. We have typically we have a known quantity of fresh air, and we know what the blowers would been selected for. If the fresh air quantities in the field, for example, needed to be increased, and we had a direct space control temperature program sequence enabled in the unit, if the fresh air requirement increased and the capacities the unit were originally built with could handle that, then we would just simply need to go into the control system and actually turn on the high fresh air sequence option code to accommodate that.
Excellent. Thanks, Pat. The next question is filtration question. Customer has an existing MERV 8. Can we put a MERV 13 in there? Answer is yes, of course. As I mentioned earlier, we have 4-inch filters, so we can accommodate MERV 8 and MERV 13. If you're putting MERV 13 back in, you may want to go back in and check your blower. I mentioned the fact that we can do basically a test and balance mode with pressure taps that we have in there, and the dynamics of your system are going to change. So we just need to go back in and re-verify the CFM. Next question is regarding commissioning. Yes, we do offer factory commissioning for our outside air units, and that can be scheduled, and we can quote you that when we quote you the unit originally. Warranties, as I mentioned, the warranties, we have a 5-year compressor warranty option as well as a 5 or a 10-year heat exchanger warranty option. Yes, we have these units. Somebody asked about existing units. Yes, we have units running out in the field now and have been quite successful. Matter of fact, I was on a job site Thursday that has one of our R7 units operating in the field. So running well. We are using the digital modulating scrolls with the R7 like we are in our Y series. So as you would expect, the lead compressor is a digital modulating scroll, and the lag compressor would be fixed. And obviously on the smaller tonnage units, we only have a single compressor. That is the last I see. I'd like to thank everybody for their time. What's important to note, if you visit our website at www.soairc.com, we have product selection links. So if you have an outside air application or either 100% outside air or high outside air, if you go to our web form, it'll help us assess your needs. And then gives us a starting point to begin the conversation selecting equipment that will be best for your application. I feel this is a very useful tool because you can use it yourself to kind of get your head around what are the questions that you should be asking your customer and what are the solutions that you may want to provide. So I encourage you to go to our website and take a look at that. Shortly, we're also publishing both a pre-commissioning video as well as a commissioning video on our website. So stay tuned for that, and we'll get that to you as soon as it's finished editing. That's it for today. Pat, thank you for being with us. Thank you for attending, everyone. Again, reach out to us if we can provide further assistance to you. You've got our contact information. Visit our website, and we look forward to helping you with your solutions for PDF, for purification, dilution, and filtration. Thank you. Appreciate your time.